Honored to be here today. Bonjour, merci. At its core, my work is about how we can use machines to understand the world around us. To look across the rich tapestry of global information each day, telling the diverse stories of our shared planet, and to visualize, understand, and even forecast the future. Last year at Web Summit in Lisbon, I talked about how we're applying AI to make the Internet Archive's television news archive searchable. The TV News Archive spans 300 channels from 50 countries on 5 continents in more than 150 languages and dialects, spanning more than a quarter century. But for the first 20 years of its existence, it just sat as files on disk because we lacked the tools to make it searchable. No journalist or scholar that's interested, for example, in how Russian television news is covering Ukraine could watch all of that coverage and try to assess, okay, what's happening here? How are they covering? How are they framing this? So we needed somehow to make it searchable. So a few years ago, along came large speech models. So again, we've had speech transcription tools for a very long time now, but historically those tools supported a limited set of languages, but most importantly, they typically supported only one language per broadcast. Now, as as Canadians well know, much of the world is very multilingual. Take Algerian television, for example. You might have English, Arabic, and French in rapid succession in the same broadcast. Uniquely, in the United States, when we hear a broadcast from another country, typically it is dubbed into English. So if President Putin is speaking, we won't actually hear him speak. We will hear English overdub of it. But in most of the world, you will actually hear him speak in the native language, and they will dub it. Sorry, they'll put subtitles there. So that means that we need tools. We needed speech tools that could actually handle all of these languages, and large speech models actually did that. And so we were able to transcribe the spoken word of a quarter century of global television news. 3 million hours of uncaptioned television, totaling 14 billion words across 150 languages and dialects. But of course, television is both spoken and visual. It turns out there is a lot of text on television news. So we went through all 19 billion seconds of it and extracted out all of the on-screen text. 6 quadrillion pixels we had to examine, yielding 294 billion words. Now, what's interesting about OCR, libraries have been scanning books and turning them into searchable text since computer vision first came along. So typically, when you think about OCR, you think about a huge amount of imagery being condensed down to a very tiny amount of text. But it turns out when you operate at this scale, the text is almost as big as the imagery. We end up with 2 petabytes of JSON annotations just for that on-screen text. And so it's not just the methodological challenges, there are the technical challenges of how do you index, how do you process that much? How do you deal with the fact that an on-screen ticker is moving to the side? In some countries, you actually have on-screen text moving in both directions at the same time. How do you think about that? How do you deal with words being cut off continuously? How do you index that? How do you make that searchable? So you can imagine we have the spoken word now indexed. We have the on-screen text index. So then we had Gemini watch all of that material and catalog it second by second. And then what we're doing now is we're starting to ask, well, what about the stories that television tells? What we ultimately want as a journalist or scholar, instead of looking at an hour-long broadcast, I want to know, okay, what are the actual stories that are being covered there so I can jump right to those? So in the United States, for example, an evening news broadcast, 30 minutes covers 5 or 6 stories. So but they're not linear. It's not like story 1, story 2, story 3. Typically, it'll say, here's story 1, now here's story 2, now back to story 1, now we're in story 3, now we're going to go back and talk about intermixing of these 2 stories. Now we're back to here. So it's very, very nonlinear. It turns out these models are really, really good at looking at that broadcast, teasing out and saying, there are 5 stories here, and here are all the segments for each of those. So now a journalist or a scholar can say, okay, I want to look at Russian television today and see how they're covering the US-China summit. And then instantly see as an index, here are all those segments within those broadcasts. And that's a really powerful thing. If you think about that kind of indexing, it's not just keyword search, it's semantic indexing of a kind that we really haven't thought of before. Now, for the machines, we prefer the machines to operate in the native language of each broadcast. Machines support hundreds and hundreds of languages now fairly well. And importantly, connotations vary. When you translate something, you lose a lot of meaning there. But remember, our core kind of constituency for this are journalists and scholars exploring public interest questions. So there are very few journalists and scholars that speak hundreds of languages. So we have translated all 6 billion seconds of international coverage into English now, totaling 62 billion characters. Now, what's amazing about this is that costs just $74,000. Oftentimes, you think about translation at this scale should cost an enormous amount of money. The fact remains that costs have come down so much now at scale that it's really possible to do things that we couldn't even imagine in the past. And what's even more interesting is that historically, translation had a lot of issues to it. Having done a lot of spot checking on this material now, it's actually, hallucinations come down for the translation task alone to a point where you don't really see that existential translation, at least in this domain. And I want to emphasize, no data is used to train or tune any models. So we're a nonprofit, the Internet Archive is a library. We are exploring how journalists and scholars can use this material. So we're using only the off-the-shelf models. And that, again, is very important because, again, today you hear all these companies, building models, building models. We're on the other side of the fence. Our question is, okay, great, we have all these incredible AI models out there. That's great. How can they actually be used to answer real-world questions that have real public interest importance? The end result is an index. Very soon, you'll actually be able to keyword search all of this content. But here's the thing. Searching implies you already know what you're after. So the question is, how could AI help us know the questions that we didn't know to ask? Because oftentimes, the most interesting stories are things I didn't even know to ask. If I'm a journalist or a scholar, I can say, okay, I'm interested in inflation. I'm going to go search for how often inflation was covered, or whether it was gas inflation versus food inflation. But again, what I want to know is, okay, these bigger questions. What's Iran saying yesterday? What is Iranian media? How are they framing this? Or more broadly, what's something interesting that would be really, really important for my constituencies to see? So the question is, how can we use AI to do that? Well, to explore this question, we've been asking Gemini to make infographics. Now, you might say, why infographics? Well, here's the thing. If I have a one-page document, and I have a 10,000-page document, and I ask a textual model to distill those down, to say kind of what are the high-level findings here? Well, it might be a sentence or two for the one pager. It might take a few pages or a few tens of pages to do that larger document. The larger it is, the more complicated it is. A textual model will just take more space. But when you visualize something as an infographic, whether I have one page or 10,000 pages, it's still the same number of pixels. So it forces the models to make hard decisions on what are the details that matter. But even more interestingly, when I go from text to text, that's still one modality. When I make an infographic, I'm changing modalities. I'm going from text to imagery. Think of the image that pops into your mind when I say the word innovation, or AI, or robotics, or Canada, or nature. Probably in your minds, you're thinking of one particular image. But here's the thing. If I'm, for example, looking at a particular report, I can't just pop out, go to Google Images, type in the word innovation, and grab, take something that looks like the first image I see there. That image has to really be contextual to that particular article, whether this is government innovation, tech innovation, climate innovation. And so the models have to not only think about, well, how do I transfer that modality? What image would best represent this? But I also have to fundamentally restructure things. If I'm taking a large document and distilling it down, I'm mostly just being an editor. I'm removing sentences, I'm rewording a few things, condensing things. It's editing, not really reasoning. But when I visualize something, I have to fundamentally restructure something that's meant to be read linearly into something that's very non-linear. I have to think about a new way of representing that. And so infographics really force these models to reason, again, quote unquote reason or think, but it really pushes every piece of those reasoning. And here you can actually see, this is my talk from Lisbon, and you can see the talk, the 20-minute talk becomes one infographic that actually does a really good job of capturing the core focus of that talk. Now, we've been scaling this up to everything imaginable. Academic papers, research proposals, backgrounders, resumes. And again, Web Summit at its core is a startup conference. So all of you are very, very familiar with raising funding, doing pitches. I've gone back to a lot of proposals that I've done in the past and had it turn into infographics. It's incredible. Now, again, most startup founders today, you've already taken your pitch, you've plugged it into the different models, you've asked them to reword it, you probably asked them to role play with you as an investor. But I'll tell you, nothing is the same as actually going and having a model make an infographic of it. It crystallizes and distills your core concepts because, again, there's no room for verbosity. It has to surface only the single most important key concepts there. And I'll say, after my talk, go to Gemini, put your resume in there, and just say, make this into an infographic or a superhero comic or whatever you want. It's really, really incredible how it distills out those key pieces of it. But of course, again, a lot of my stuff's tech, and you might say, well, these tech companies are making these models. Of course, they're good at this. So we went to Wikipedia, and we said, let's just grab random articles from Wikipedia and turn those into infographics. So literally, just copy and paste the text in and say, make this into an infographic. What's amazing about this is every one of these, you'll see, it's not like a template and it changes the text and imagery. Every one of them is completely and utterly different. And what's so fascinating here is ask it about 1800s railroads in the US. The imagery, the fonts, the iconography matches things from that period. Ask about the Venus flytrap. For those that aren't familiar, this image and the iconography there matches, actually, the original scientific visualizations of the Venus flytrap. So it's really, really fascinating how it chooses. And to me, there's so much power for educators to use this. Again, we're thinking, a lot of times when we think about education and AI models, we're still thinking in terms of text. We're thinking about text bots back and forth. But the ability of visualizations to fundamentally change how we think about information. Now, that in turn got us thinking, well, have any of you actually read the text of the laws of your country? I'm based in Washington, D.C., and I'll tell you, you pull up a random bill from congress.gov, from yesterday, and it'll say, delete paragraph 2, insert this word here, change this word, go to paragraph subsection C4, whatever. And by the time you get to the end of it, you're like, what exactly does this law do? And so one of the things is we started having the models, actually, we just took random laws, federal, state, and local, and just said, make infographics of this. And it's incredible how accurately these things actually are able to distill down and look across all that, and even take something that's, some laws are literally just modifying a previous law, and it's able to go back, combine those, and do that. And honestly, I think governments, there's an incredible opportunity for governments to use things like this to communicate how they're helping their constituents. And then we said, well, okay, so it's one thing to visualize one law. What about if we think about most of government is hearings, it's committee meetings, it's all of these things like you see at the top there. It's people sitting in a room talking. And, like you read some of the, you go to some of the, so Internet Archives in San Francisco, so we've been looking at some of these San Francisco local meetings, and, you see like a multi-hour, hearing, and it's just people there talking. And you'll see a reference like, I agree with point 2 that was mentioned 10 minutes ago. And, I go back and I say, well, wait, what point, where, 10 minutes, how? Or you see a bunch of this, and at the end of it, you're kind of asking, well, so what are they actually saying there? Like what exactly, because again, I'm not a policymaker. I don't know, I don't really understand all this stuff. So by changing the infographics, then it says, oh, well, they decided to change trash pickup from Tuesday to Wednesday because of this, this, and this. Oh, that makes perfect sense. Now I get it. And again, I think there's tremendous opportunity for governments to use tools like this to help communicate to their public how they're helping them. But the real power is how we can look across enormous amounts of material. So in the United States, each year they put out, this essentially it's a blueprint of sort of defense priorities. So remember in the beginning, I said, like, what about a one-pager versus a long document? This document, 3,100 pages into one infographic. And what's fascinating about this is, again, the NDAA, it's structured for government bureaucracy. So it's structured how government thinks. Versus turning it to an image is something very different. You've got to go through tens of thousands of distinct details and figure out which of these matter, what should it go where. And then we actually transform it to the entire US government budget. Now, this is actually really interesting because I didn't say organize it by department, add in a little graph on the right, talk about the changes from the past years, talk about priority changes there. It went through that entire budget and decide, okay, here is the best way of presenting this. Here's the most intuitive way of presenting that. So I didn't actually tell it to do this. But what's interesting, again, is you can actually say, okay, I want you to target this audience, and it will pick visuals attuned to that audience. Again, pushing the reasoning capacity of that. But where they really shine is in comparison. So we said, if you look at the English language Wikipedia about Russia's invasion of Ukraine versus you look at the Ukrainian Wikipedia versus the Russian Wikipedia, or when we did this, Grokpedia had just launched. It was presenting itself as the one true version of the truth. And we said, well, let's compare those. So if you handed all that text, what you get back is another large, massive report of text. And I read through that, and I said, I still don't really understand the differences here. But in an infographic, you instantly see those 4 parallel universes there. And that, again, the power to be able to do those comparisons. And then we said, well, what if we scale this up even further? So we said, let's take one entire day of a television channel from somewhere on Earth. We'll take one day of a Russian television channel, and we'll turn that entire day of coverage into an infographic. What are the top-level themes, narrative, trends, developments there? And then we scaled it up even further. On the left there, what you're seeing is one day of every channel the Internet Archive is monitoring from around the world. And what's fascinating is, again, you don't see a lot in the image up there, but when you drill into this, you can see both the shared stories that the entire planet is talking about that day, and then you can see the differences. And what's fascinating about this is what you start to see is all the stories that I don't see in my own country's media. And so you start to understand that when I watch the media in my own country, I'm only seeing a tiny, tiny glimmer of the world around you. The ultimate result of all of this is this. Every day, we have Gemini look over the legislative activity of the US government. And every day, we're expanding out the amount of material that we pour into this. And we say, I don't want a summary. I don't want a giant list of the 500 bills and different things that were discussed yesterday. I want a 60,000-foot view of the legislative activity of my government. And so we have Gemini sit there, crunch through all that, and each morning produce this. By the way, this is a free and open report. You can get this now. blog.gdelproject.org. You can subscribe for this. You'll see the link to subscribe to this. And so what we do is it starts off, it looks at the entire yesterday, all the different legislative activity, and then it does a day of a glance. What are the top-level themes, narrative trends? Then it does a deep dive. What are these? And then, towards the end of the report, we actually ask it to forecast. And we say, based on the current trends, where do you see that going? And this is both a useful tool, but also a benchmark of where is the state of the art of reasoning today. And right now, we're using Gemini 3.1 to do this. We're going to start exploring, what if we also bolt additional reasoning tools on top of this? What can we do? How far can we push the reasoning capacity of models today to be able to distill down the entire world down to something that's understandable? And we've scaled this up now. So we started with the US. Now we're taking each country that the Internet Archive each channel that the Internet Archive monitors and doing a similar report. So again, distilling it down and then making an infographic. And again, that idea, that duality there is how, each report, I can kind of look and say, well, how well does this visual representation capture the text? What is the strengths? What are the limitations of each piece of this? And for us, a big part is to really start understanding, again, both the strengths and the limitations of these. And again, all this done in the native language. And again, this scaled up, you can go right now, again, blog.gdelproject.org, you can get this newsletter, each report, one report per country. And then, this got to start asking this question. Could I make an agentic think tank in a box? So, former journalist here, technically a columnist, I'm still on the mailing list of almost every think tank out there around the world. So every time something happens, which is pretty much every day, I get probably close to 100 emails pouring in from every think tank, offering the quick take of all their experts. And that got me thinking, usually when you read through these, it's not much. It's, okay, so there's a blockade, here's what probably will happen. And it's not something that's like deeply researched. It's something quick that they wrote in, 30 minutes. So it got me thinking, this is kind of something a model might be able to do. So we did an experiment. We had it watch Iranian state television for a day, and we said, okay, come up with 5 mediagenic reports, and then actually write each of those reports. And then we took those, and I went through my inbox and found some of the quick takes that have been sent by some think tanks, and then stripped out the logo, stripped out all identifying information, and I sent those to some folks, and said, one of these is human, one of these is AI, which is which? Unanimously, they picked the AI as the human. And they said, there's no way that an AI could do this. This is too deeply done. This is too well researched. And then we said, okay, well, let's step back even further. What about backgrounder reports? So, when the blockade occurred, I don't need a quick take to tell me there's a blockade. But maybe, I vaguely remember in the 70s or 80s there was some blockade that occurred, but I don't really remember all the details. I Google it, I get a Wikipedia page that's, 500 pages long, and my eyes glaze over. And just kind of give me the quick take. What kind of happened last time? How did it get resolved? Or this new, leader that was elected. Who is this person? I don't know much about them. And so we used a separate prompt, and we said, go through and find the things that journalists, scholars, members of the public might benefit from a backgrounder, and research and write that. And that got us thinking, what about an agentic think tank in a box? So the idea here is, an agentic persona-based news recommender. So the idea here is that you write a description of who you are. So for example, US automotive manufacturer, assessing how tariffs and trade wars can go. And so you write this, and then Gemini goes, it takes all of the coverage that we monitored across the planet in the last 24 hours and finds all the stuff that's relevant. And it doesn't give me a bulleted list of 5,000 links. It says, here are the top 10 trends, and here are the key articles that are relevant to me versus someone else. So each person that does this would get a different report based on who they are. And you notice, I didn't say what I'm looking for here. I said who I am. And the model then goes out and finds things that I might not ever have thought to look for. So again, serendipitous discovery. And what's fascinating about this, actually, is when we ran this, it actually found on this particular day, there was a consumer products company that was reporting that they were having a shortage of a certain type of stainless steel for their products. Notice, this persona right here mentions nothing about stainless steel, but it knew that that particular automotive manufacturer that was in here uses that particular stainless steel and flagged that and said, hey, we're starting to see the reports of this. This is probably highly relevant to you. Again, I never probably would have ever thought to keyword search for every single type of material that my company needs. Again, the model just looks for that. And what's fascinating, again, you can do any topic, any persona, any task. You can ask it for a particular task or just say, this is who I am. Go find things that are interesting to me. And you get back reports, and you can't see it here, but each of these little things is actually a link that connects back to the sources that are specifically relevant to me and my particular needs. But this is where things get even more interesting. That's still me as a human being expressing who I am and getting information back for me to personally act on. We started asking, well, could the machine just take action? And I'm not talking agentic, do this or that. What we said is we had it watch Iranian state television. Again, this is before the conflict. And we said, monitor for any mention of the nuclear accord. If it's negative, write a point-by-point rebuttal. We said, Gemini, you are the US State Department, and then write a rebuttal from the standpoint of the US State Department. In English, in Farsi, for different outlets, different countries, et cetera. What's fascinating is we took the output of the model, took some of the actual outputs of the US State Department, again, ran them by people who were like, of course, the AI must be the human. There's no way it could be. I mean, it was amazing. Country by country, it was actually good enough to pick out key connections between the two countries and leverage those in part of its argument, which the State Department actually missed in a lot of cases. Now, whether this is amazing or this is really frightening, the future is here. Fully autonomous diplomacy is here. You can imagine literally bots negotiating things together. But there are still limitations. So right before coming out here, I asked Gemini Deep Research to give me a country-by-country breakdown of the impact of the blockade on every country on Earth. Now, you'll notice there's something wrong with this report here. Europe, it flagged and said there's almost no impact on Europe. Now, this wasn't a hallucination. This wasn't an error. What happened is the model simply ran out of tokens. So remember, these models, even the most advanced models today, are still very, very limited. So when we ask big questions, they run out, but they're not smart enough yet to flag, hey, wait, I'm running out of memory, and just put a little warning there and say, hey, I ran out of tokens before I could get to Europe, so I'm ignoring that section of it. Conversely, if you just ask about Europe, it has enough tokens to actually produce a quite interesting report there. So that leaves that question. How can I reason over the entire planet? I want to build a representation, a live, real-time representation of the entire planet that I can reason over. So you think about this, typically you'd say, well, I'll use RAG. But RAG is designed to say, here's this enormous volume of material. I only care about a few little things here. I care about the needles in a haystack. But remember, I'm not looking for a needle in a haystack. I'm trying to describe the contours of that entire haystack. Or you do distillation. You say, I'm going to take the material and keep condensing it downward. The problem is, by the time you get down to something that's manageable, you've lost all the detail that the reasoning models need. So instead, we're starting from the bottom up. So you take one day of the entire planet. Every tiny little pinprick on here is actually a story from in one particular day on planet Earth. So we're starting by taking that, zooming into one microscopic corner of that. And then zooming all the way down to the underlying stories that sit underneath that. And then zooming all the way down to the individual petascale and exascale connections, the graphs that, if you sort of think about it, it's sort of an atomic level view of the planet. And what's interesting is when you zoom all the way down to that level, you can start parallelizing this question of pattern recognition. You might say, well, wouldn't the patterns disappear? Isn't it easier to find patterns up here? Possibly, but again, until we have models that can take the entire planet, that can take petabytes of data in one context window, then maybe, absolutely. But even then, oftentimes when you look at that much material, so it actually turns out, if you ask models to compare imagery in particular, they spot check just like humans do. So the very things that we would think like, oh, an AI model should be great at taking all this material and looking at it once, it turns out that as you scale upwards, the models start taking the very same shortcuts that we do. But it turns out if you drill all the way down and you give them this finest level of detail, we can also start applying other techniques, more traditional techniques. Graph reasoning, geospatial reasoning, temporal anomaly detection. We can start bringing in a lot of really powerful non-transformer based and other types of AI models into this. And then on top of all of that, we can then do, so once we have all that material then, we can start sifting out these patterns and then using the models to really start extracting out those underlying patterns and then lifting those upwards. And so the end, our ultimate goal here, what we really want to be able to do here, is to be able to go from all of sort of taking the entire planet, taking all this material on the entire planet each day, and getting to simple representations like this. To go back to what I showed you in the beginning, those, one report per country. What I want to be able to do is do that for the entire planet each day. So, coming later this summer, we're going to relaunch our Global Trends Report. It'll be about 600 pages. Again, one chapter per country, one chapter per topic. So the idea is to say, what would it look like to take everything said across the planet yesterday in all the world's languages, from all the world's sources to the best that one can do, take all of that, reason over all that, and to say, here are the high-level trends for each country. Here are the high-level trends for each topic out there each day. And then to ask the models, forecast the future for me. Tell me where things might go. Give me different scenarios and trajectories for what might actually occur here. And you will see at the end of this summer, the end results are actually really, really incredible in terms of one of the things to think about when you think about these models is, most of these models, it's no secret, they've been trained by sort of ingesting everything that can be found in the world, anything in the digital world. So when you start thinking, take something like the blockade, as a human being, we probably remember, even if you're an expert, you know one little tiny slice of that. But when you suddenly have access to all of this material from across the planet, and you can conduct research and bring all these, we have, with the Television News Archive, a quarter century of television, in our own archives, about 50 years of global material. And when you start looking across all of that and start extracting out all of the patterns across that, you can start really, really contextualizing and finding things that no human being could ever do. And again, the goal here is not to summarize. What we're interested in is, what are the patterns that only become visible when I look across millions and millions of articles each day? When I can consume everything on Earth, what are those patterns that become visible? Sort of a real-time model of our planet. And again, this is a journey. This is a journey that we're just beginning. Our North Star is really the world's grandest challenges, the biggest, most difficult challenges out there. We're not out here. We're not a startup building models or selling things. Our goal is to answer the world's most difficult questions. So thank you so much. It's truly been an honor to be here today. I hope you join us in this journey. And again, go to blog.gdal.project. Thank you so much.